When you glance at your phone in the dark, it projects 30,000 infrared dots to map the unique geometry of your face. Within milliseconds, it identifies you and unlocks. We experience this as a seamless, intuitive interaction, as if the device possesses a small digital brain that recognizes its owner. This experience is a byproduct of high-speed calculation, not consciousness. Despite how natural these interactions feel, the technology lacks any human comprehension or self-aware thought. It is not thinking through a problem, it is executing a sequence. To understand why this technology is shifting the course of human history, we have to look past the interface and view it as what it actually is: an incredibly fast guessing machine built entirely on the foundations of multidimensional math. This graph illustrates the absolute baseline of predictive mathematics. If you plot 2 points on a 2D plane, you can draw a linear path between them to estimate what might happen in the middle. You are using existing data to make a logical guess about a new value. Large-scale AI models operate on this same principle, but they replace 2 dots with trillions of data points harvested from the internet. To account for all that information, the math cannot stay in a straight line. It has to bend and twist into a highly complex, multi-dimensional shape that intersects as much of that data as possible. Refining this shape is a process called training. Computers run through the data millions of times, adjusting digital dials to ensure the curves of the math match the patterns of the information. Each of these dials is a parameter. The more parameters a system has, the more complex its guessing shape can be. This vintage calculator is an example of a simple rules-based form of artificial intelligence. It follows fixed, human-written instructions to reach a specific result. While it lacks the flexibility of modern systems, it serves the same broad goal: using a machine to mimic a human cognitive task. We reach deep learning when we stop giving the machine fixed rules. Instead, we provide it with a digital network inspired by the human brain and let the system identify its own mathematical patterns within massive sets of unstructured data. Large language models apply this pattern-finding logic to human speech. Because computers only process numbers, they must first translate English words into numerical fragments called tokens. This visualization shows how the AI organizes those numbers. It plots every token as a specific set of coordinates inside a massive 3D spatial room. In the tech industry, these specific locations are known as embeddings. The geography of this room is based on meaning. Words that share similar traits, like cat, dog, and puppy, are clustered physically close together. Conversely, a word like spreadsheet is located a vast distance away because it shares almost no mathematical relationship with household pets. When you prompt a chatbot, it calculates its way through this map. It looks at the words you provided, finds their coordinates, and predicts the single most logical next word. It repeats this calculation for every single word in its response. Even when the output appears creative, the machine is simply identifying the shortest mathematical path between related concepts in its spatial map. However, a static map cannot account for tone. The word great has a positive coordinate, but that meaning changes if it is preceded by the word not. Modern AI handles this through the attention mechanism. Before predicting the next word, the system looks backward at everything that came before it. The word not effectively pulls negative energy into the word great, altering its mathematical state before the next calculation begins. This shift tells the AI to ignore the positive sections of its map and instead look for its next word in a corner associated with disappointment or sarcasm. This mathematical ability to weigh the context of surrounding words is what allows a machine to mimic the nuance and flow of human conversation. This same logic applies to visual data, like this chest X-ray. Just as the AI assigns coordinates to words based on their meaning, it can assign numerical values to the brightness and position of pixels. By comparing these pixel patterns against millions of previous scans, it can identify anomalies that match the mathematical signature of a specific disease. Whether analyzing a poem or a medical scan, the system performs a high-level statistical analysis. It lacks a soul, lacks intent, and has no conceptual understanding of the results it generates. AI is a tool of pure pattern recognition. Today, it remains the most sophisticated version of connect the dots in human history. It's a machine that has found the invisible patterns hidden in human language and behavior.